welcome back. Today is day 3 of logs, and today we're going to talk about two distinct types of logs. And one is the common log and one is the natural log. These are two places that we will be working with frequently. Okay, the first one we have here is the common log, and the common log is a log with a base of 10. And common log is what we actually use on our calculator. It's the only base that the actual calculator understands is base 10. And we do not need to write the base as a subscript when the base is 10. So if you ever just see a problem that says log of a number, that means that it is base 10. So that's something you need to remember. Okay, we have some examples here. Example 1 is find log of 23.75 to the nearest 10th. Well, this is just a calculator problem. So on your calculator, you would hit the log button, and then you type in 23.75, and then you hit enter, and you would get 1.3756, blah blah blah. Okay, and if I need to round the nearest tenth, I need to look for the nearest hundredth, and that would be 1.4. For number 2, we have log x equals 2.87534. And we need to find x. And I think the nearest tenth is just to print out here. So I'm just going to write that Okay, we've been working on these. This is log form, so I need to turn it into exponential form or bend form. So define what your b, e, and n are. Remember, when it's just log and there's no subscript here, my base is 10. Here's my exponent, and remember a log is just an exponent. So 2.87534, and my number is x. So if I'm going to put this into bend form, my base is 10. My exponent is 2.87534 equals x. So I literally am going to look on my calculator and type this in. This would be second log on the calculator. And when you type it in, you'll see 10 caret, and then you fill in both in the parentheses. In this case, you put 2.87539 in its place. And when I do that, I get 750.48 and a bunch of other things equals x. The nearest tenth would be 750.5. Evaluate to the nearest hundredth. This we just simply type into the calculator. And I hit the log button, and parentheses will come up, and I will say 64. Close my parentheses. You gotta make sure you close your parentheses. Minus, hit the log button, parentheses 16. And when I do that, I will get 0.60305999113. The nearest hundredth, 2 decimal places, so 0.60. And yes, I need to have that 0 there because it's at hundredths place. Even though it's 0, I still have to have my 2 decimal places. Alright, next example is with natural logs. And the natural log is a log with the base e. a log without a number base is base 10. This is base E. Remember, E is just an irrational number. Excuse me. We abbreviate natural log with ln. So find the ln of 23.75. Okay, and I make around that to the nearest 10. So I literally type in on my calculator ln, and then we get the parentheses 23.75. And when I do that, I would get 3.16758.253. The nearest tenth is 3.2. Again, the nearest tenth should be over here as well. So I have the natural log of x equals 2.87534. Well, again, I have a log, and I need to turn it into exponential. So B, E, and M. Now my base is actually E, the number E. My E is my exponent, which is what the natural log is equal to, so 2.87534, and my number is x, and that's what we're looking for. So I have E, 2.87534 equals x. On the calculator, it's second ln. And we used this in the last chapter when we were doing some of those equations and word problems. And when I type it into the calculator, I get 17.73145, a bunch of other things, and I'm rounding to the nearest tenth, so x equals 17.7. Number 6, again, is just a calculator problem. ln, and the parentheses, 64, subtract, ln, 16, close the parentheses. When you do this, and type it into the calculator, you get 1.386294361. Nearest hundred, two decimal places, and I round to be 1.39. Hang on 1 second. Okay, I'll fix that. Alright, I know I said before that if we are using a calculator, we have to be in base 10 or in base E, which is our natural log. Those are the only two buttons that are actually on the calculator. But it doesn't always work that way. Therefore, we need a way to be able to use our calculator and still get answers. So, in order to be able to use the calculator, we have what we call the change of base formula. And we can use this for more than just typing into the calculator. You can also use this for solving equations, which we'll get to later this week. So, my change of base formula is log base b of n is equal to the log of the number divided by the log of the base. Or, if I have the log base b of n, I could use the natural log of the number divided by the natural log of the base. So use a calculator to evaluate the following logarithms to the nearest hundredth using both common log and natural log. So all I'm going to do is use my change of base formula using logs and using natural logs. So in this case, I would say the log of the number, which is 30, divided by the log of the base, which is 5, and I'm rounding to the nearest hundredth, it would be 2.11. The other way to do this problem is to say the natural log of the number divided by the natural log of the base and put it into the calculator, and you'd still get 2.11 rounded to the nearest 100. Same thing here. We have the log of the number, which is 6, divided by the log of the base, which is 1/2. And when I put that into the calculator, make sure you have parentheses around the denominator. So to type this in, it would actually look like log parentheses 6 divided by the log of 1/2. And when you do that, you get negative 2.58. Or I can use the natural log of 6 divided by the natural log of 1/2. And again, if I put that into the calculator, I still get negative 2.58. So when you're actually using the change of base formula, it doesn't matter if you remember it with regular log or with natural log, you will get the same answer either way. Alright, I hope this was short enough for you, and I will see you in class. In the next 2 sets of notes, we will be solving equations dealing with logs and exponents, and we have 2 methods of doing that. Then we will review, and we will test probably on about Wednesday of next week.